We're solving equations with variables on both sides. Now, a lot of times when you solve equations, you don't have to, but sometimes it helps to make a line down the middle to separate the two sides. So, our goal when we solve equations with variables on both sides is to get the variable or the letter on one side. And I usually like to get them on the left side. So basically, I want to move this negative 7x over here. The opposite of minus 7x is plus 7x. That leaves me, when I cancel right here, that cancels. I get 19 over here. 3x and 7x gives me 10x. Bring down the minus 1. Now, the next step, I want to get x by itself. So all the x's got moved over. Now to get x by itself, you take away or you move the pieces farthest away from the x. So the 2x is connected right up next to it, so we get rid of this minus 1. A minus, the opposite of a minus is a plus. So you're going to add 1 to both sides. That's gone, leaving you 10x over here, and over here you have a 20. Now, we still have, I have that line, or you can just start putting your equal sign, whatever you want. The last step, some of you could look at this and tell x is 2. But the last step is that 10 is connected to the x by multiply. The opposite of multiply is divide. So you're going to divide both sides by 10. That's gone, leaving you just x. 20 divided by 10 is 2. What does that 2 represent? If you plug 2 into both those x's, you should get the same value on both sides. Alright, you do not have to always put this line down the middle. It just can help. Some people need the separation. Got to keep them separated. Now, here we want to do the same thing here, but before we get the variables to one side, you first have to simplify each side. So look over here. Can we simplify anything over here? Can we combine anything?
Yes.
Yes. Don't those combine?
Yes.
8 and 7 gives you 15.
Yes.
Over here, the a's combine. Negative 6 and 2 gives you negative 4a. And then bring down the 2. So over here we combine the 8 and 7. Over here we combine the 2 a's. Now we're nice and neatly simplified. You can put the equal sign if you want. Now we look a lot like this problem. I want to move the a's over to this side. So that's a minus 4a, so I add 4a to both sides. That's gone, leaving me 2. Bring down the 15, and negative a plus 4a gives you a positive 3a. So, next step. I want to get 3a by itself. So the 15's out here farthest away, so the opposite of a positive 15 is a minus 15. That's gone, leaving you 3a, and then 2 and negative 15 combine to give you negative 13. To get the a completely by itself, you divide, because that's 3 times a, the opposite of times is divide. That disappears, leaving you a. And this does not reduce. You can either write it as 13 over 3, or 3 goes into 13 4 times, with a remainder of 1.
4 1/3.
Either of those answers work. The last problem. When we're solving, the first step we want to do is simplify each side. So we want to first simplify this side by distributing. So 6 times 3 is 18. 6 times negative n is negative 6n. Over here we want to distribute this. So negative 2 times 3n is negative 6n. Negative 2 times negative 5 is positive 10. So, we distributed, we simplified both sides. Can you combine any like terms?
6n.
No, you can't. On each side, you can't combine anything. So our next job is to move the ends to one side, and preferably the left side. So to get rid of this minus 6n, you're going to add 6n. Because the opposite, that cancels. Wait, what happens here? That's gone. All my ends disappear. I can't solve anything. I'm done. It fell apart. Now, is this a true or false statement? Does 18 equal 10?
No.
That is false, right? This is called a no solution. Meaning, there is no answer to plug in for n to make this work. Now, one thing you got to be aware of. If everything cancels out like this, and you end up with like 18 equals 18, that's a true statement, right?
Yes.
That would be infinite solutions, meaning any number you plug in works.
Which one's that?
So, again, if what's left over is true, it's infinite solution. But in this situation, it's false, so it's no solution.